resultant from non-uniformly distributed load. So generally it is expressed by a triangle, and you are given the height of the triangle in terms of the load per unit length, in this case 10 pound per feet, something like that, and you got it 100 feet of that non-uniform load. So the very simple calculation, simply you calculate the area under the curve, that will give you the total load coming from this triangle. So simply the area under the curve would be half times base, which is 100 feet in this case, times the height, which is 10 pound per feet. So that's going to be total 500 pounds from this non-uniformly distributed load. And also it will act from the center of the triangle, and as you know, the center of the triangle is approximately somewhere here, 1/3 from the left side in this particular scenario of the total distance. So 1/3 of 100, or 2/3 from the right side in this scenario. So 2/3 of 100. So from the left side of the triangle, it's going to be 33.33 foot. So we know the location of this non-uniformly distributed load. We also know the amount of this load, and also we have another load, this 50 pounds concentrated load acting right here. Now so the total load from this non-uniform and this 50 pound would be simply add these two, so this will give you 550 pounds total load. Now the most important piece here is to find the location of that 500, the resultant force. So the location would be somewhere along this line. We don't know the exact direction, but it's going to be somewhere in this direction. So let's say it is D distance away from the left side, say point A. So D distance away from the left side. Now, according to the moment principle or Barignon theorem, we know that the moment produced by this resultant force, which is 550 pounds times the distance D from the left side, let's say we're taking moment with respect to point A, this will be exact same as the moments for their component forces. So the 500 pounds times the distance from A, which will be 40 plus 33.33 foot, plus this 50 pound concentrated load, and that is 40 plus 100 plus this is 10. So 150 foot from point A. Now if you solve for D, I found that is 80 foot from the left side. So this distance is 80 foot. So the location of the resultant of these two forces is this. So very simple to summarize: non-uniform distributed load, calculate the area of the triangle, and the line of action would be either 1/3 or 2/3 depending on which side you are looking at, and then you can add the other forces, like in this case this 50 pounds with that.